Let's now finish up with the last section in Chapter 6 that we're going to do. We're only going to have 3 sections. Again, remember that we won't have a test on Chapter 6. We'll just have a quiz, and then it'll be combined with Chapter 7 for the last test before our final. Now, if we go back for a moment and think about what we did with our last section, on ellipses, and we look at the general form when it's centered at the origin, it was x squared over a squared plus y squared over b squared equals 1. Well, this time we have x squared over a squared subtract y squared over b squared equals 1. That is called a hyperbola, and the only difference between those two equations is this one has a negative sign. It has subtraction instead of addition between the two. The diagram you get for a hyperbola kind of looks like two parabolas back to back. In this case, we have one that's opening to the right and the other one is opening to the left. If it turns out that instead of x squared subtract the y squared, it's y squared subtract the x squared, then it would open up and down for the two curves. A hyperbola is a set of all points in a plane that the absolute value of the difference of the distances from two fixed points, the foci, is constant. In this case, here's our foci here and here. If I want to find the foci, I use the equation c squared equals a squared plus b squared, kind of like Pythagorean. Note how that is different again from what we did last time, where it was c squared equals a squared minus b squared, where we made the bigger one be first. Here it's addition, so it doesn't really matter which one's the bigger one. They'll give you the same c. So again, the only real difference between a hyperbola equation and an ellipse equation is that negative sign. Now, unlike what we did last time where we graphed a whole bunch of points, this one's going to be more of a sketch. And that's because we find that if you draw a box basically through the two vertices of the hyperbola, and then you draw lines, diagonal lines that go through that box, your curve will actually get close to those diagonal lines. And so we can do a quick sketch of what it looks like without having to actually figure out all the different points that work. Quite a bit less work than what we had before. These dashed lines are called asymptotes. You can find them. In this particular case, it would be y equals plus or minus b over ax. In other words, it's the slope of that, b over a. If it opens up the other way, you would use, in other words, if you had y squared first instead of the x squared, then it would be, the asymptotes would be y equals plus or minus a over bx. Now, if it is not centered at the origin, then just like for circles and ellipses, we have our center HK. Again, signs have to be opposite of whatever you see inside the parentheses. But, really not as much work as we had last time. So let's go ahead and see a couple of examples, and that'll finish it up for Chapter 6. So first off, there's no parenthesis part, no h and k, so we know that the center of this figure will be at 0, 0. Now, that won't be anything we graph, it'll just be the center of the overall diagram. We also know that we have, in this case, b equals 2 and a equals 6. Again, I'm keeping the convention that whatever's under y is b and whatever's under x is a, and therefore x is always the part up and down, y is always the part, or excuse me, x is always the part left and right, and y is always the part up and down. So that will tell me, since this one has the y part first, okay, this one's going to open up and down. So my vertices, sort of the end point of the two curves, or the middle point, I guess I should say, will be at 0, 2, and at 0, -2. Okay, and again, since y's first, these things are going to open up and down. If x was first, then I would have been moving left and right. All right, so let's see. So here's how this is going to work. Okay, so I need to draw a box in which I'm going left and right 6. So basically I'm going to be going, over here and over there. And then I also want to go, the box also has to be up and down 2 above. So here and here. So let's go ahead and draw in the entire box. So here and here, and then so, one of the things I want to do when I'm doing hyperbolas is I always want to draw that box. All right, so now I'm going to draw my asymptotes. So my asymptotes have to go through the center of the figure and go through the diagonal corners of the box. Okay, and again, I'm just going to dash these up. So there's one, and now the other. Now, one of the vertices is at 0, 2, so that's this point up here, and one of the vertices is at 0, -2, so that's that point down here. So basically what this curve has to look like is I have to go from here through that point and then back that way, and then down here I've got to get close to that line, go through that point, and then back that way. Now, we're going to go ahead and actually determine some extra points just so that you can kind of see the way this will work in terms of, we're not going to have to do this each time. We're going to do a sketch more than a graph, but let's just say, for the sake of argument, let's let x equal 6. Okay, so then that would mean then that y squared over 4 would equal 2, because if that's 6 squared, that's 36. 36 over 36 is 1. Minus 1 equals 1, so add 1 to both sides, we get our 2. So that would mean then that y squared equaled 8, which then means that y equals plus or minus the square root of 8, which is about 2.8. 9 would have been 3, so we're not quite there. So that means then that I know this is going to go through 6, 2.8, 6, -2.8, and then by symmetry, -6, 2.8, and -6, -2.8. Because of course, -6 squared is also 36. So where would those points be? So first off, this is 5, this is 6, and I want 2.8. So that's going to be, roughly right there. And then -6 will be at 2.8. So -6, again, about right there. And then we got to go down. So here, and then here, 2.8, like that. So what I know is at a minimum, this graph has to do this. And then the same thing over here. Now, if I wanted lots more points, notice I went all the way out to 6 here. It would just get closer and closer to those two diagonal lines, those asymptotes. And so there really is no reason to go through all that work, because I kind of know where things are bounded anyway. And so just by putting that point and then drawing basically a line that would come close to this one through there and then close to that one, I would be pretty close to what the graph should look like. Truthfully, the only thing I'm really concerned about is, kind of what it looks like, and, is it opening up and down, or is it opening left and right? All right, and again, in terms of the asymptotes, let's see. So since I have, for this one, we're going to have the A over B, so we're going to go, basically I'm going up 1 and over 3, so this is y equals negative 1/3 x, and this one is y equals positive 1/3 x for those. All right, and those are the asymptotes. Okay, let's look at B. So now this one, we're going to have to do some completing the squares. So first off, we got 4x squared, subtract 24x, subtract y squared plus 4y equals negative 28. Pull the 4 out, so we're going to have 4 times x squared subtract 6x, and then here we're going to pull the negative sign out, so negative, and then here we'll have y squared subtract 4y, and again equals the negative 28. So half of 6 is 3, 3 squared is 9, and then here 4 times 9 means I have to add 36 there. Here half of 4 is 2, 2 squared is 4, so plus 4, and I'm actually subtracting 4 because of the set, and so I have to do subtract 4 here. So I'm going to end up with 4 times x minus 3 squared subtract y minus 2 squared equals 4. And got to have a 1 there, so I'm going to again divide everybody by the 4. I'll have x minus 3 squared over 1 subtract y minus 2 squared over 4 equals 1. And now it's in the standard form. So my center is going to be 3, 2. In this case, A equals 1, B equals 2. So the box I'm going to have is basically from the center, I'm going to go left 1 and right 1, and then I'm going to go up 2 and down 2. So we can already draw that part. 3, 2. Let's see, 3, 2. So that's where the center part is. And then from that, I'm going to go up 2 and down 2 and here and here. So my box will look like that. go ahead and draw my diagonals. Those are my asymptotes. In this case, we have y equals 2x, and over here, y equals negative 2x. Again, those are the asymptotes. Now, since this one had x first in my general form, that means it's going to go left and right. So that'll be one point here, that'll be the other point there. I know that as it goes away from the box, it's got to get closer and closer to those lines. Let's kind of approximate what we're going to do. I'm going to let y equal 8. So then that means that x minus 3 squared will equal 10. 8 minus 2 is 6. 6 squared is 36. 36 over 4 is 9, but it's a negative 9, so added to the other side I got the 10. So x minus 3 equals plus or minus the square root of 10. So x minus 3 equals plus or minus about 3.2, which would give me 6.2 and 8, and negative 0.2 and 8. And then by symmetry, since I went at 8, this has to work for negative 4. In other words, negative 4 subtract 2, that would be negative 6. Negative 6 squared is back to the 36. So we would have to have 6.2 and negative 4 and negative 0.2 and negative 4. And so if I were to graph those, let's see, 6.2 is 8. So there's about 6.2, and then I got to go up 5, 6, 7, 8. So I'm in this territory, and then I got to be at negative 4 for that. 1, 2, 3, 4. So again, I'm in that territory. On that side, the same things have to be true for the negatives and the positives. So let's see, 6.2. Let's see, and let's see, so I have to go this way at negative 0.2, so that's just barely past the line. So I'm kind of like here. Actually should be a little bit higher in those, and then down here at negative 0.2, again it will be, you know, about right in there. So even doing a graph, you can see, you know, basically I'm going to go through there, and then I got to turn around and go like that. So there is my graph. So part of what I wanted to demonstrate by doing these extra points is I don't really need to do that much effort to get a pretty good idea of what this should look like. If I draw the box and then I do the two diagonals and I put down the 2 points, my vertices, and then just kind of go through and get close to my asymptotes on both sides, I'm going to be close enough to what the graph should actually look like without having to actually go through all of this work here to get my extra points. So in terms of any quiz or test, I'm only going to ask you to basically find the two vertices and then draw the box, draw the diagonals, and then just sketch so that you know. And really, what does it all come down to? It comes down to whether you want the two vertices to be like this, or the two vertices to be like that. In other words, is it opening left, right, or is it opening up and down? How do you tell? Is it y first, then it's up and down, or is it x first, then it's left and right? And so, there you have sketching hyperbolas.